Alrighty, part B, take 2, because Darnell ruined my take 1. Whatever, kid. Where's the Orthocenter located for an obtuse triangle? You may already have this memorized, but if you don't, I would be happy to draw one for you. So here's an obtuse triangle. Children, I'm video making over here. I'm making content for my YouTube channel.
My girlfriend ate all my chips.
Well, that's why you shouldn't have a girlfriend. They eat all your food. All right. So they're going to be more quiet now, and we're going to focus on geometry. So where's the Orthocenter located? Well, let's draw the altitudes, because where the altitudes meet is where the Orthocenter will be found. Now, the thing is, the only way I'm going to make these connect is if I extend them. So I'm going to extend the altitude. All right, I'm going to extend this altitude. And we're going to make this altitude over here. Oh, it's a little crooked, don't judge. Anyway, so the blue was my triangle. My obtuse triangle. And all the red lines are my altitudes, which look a little funky because I had to make them extra long so that they would actually connect with each other. And what we notice is the 3 altitudes meet up outside the obtuse triangle. So we talked about this in class, and we looked at a picture of it, but we never really did anything with it because there's nothing really to do with it. That's as far as we go. The orthocenter is outside the triangle if it's an obtuse triangle. If it's an acute triangle, look at that acute triangle. It's so acute. Hee hee hee. Oh, guys, don't make fun.
I didn't say a word.
You didn't have to. So on an acute triangle, the orthocenter would be inside, and on a right triangle, the orthocenter, I think it's located on the triangle. So altitude, altitude, altitude. Yeah, they would meet up on the right angle. So for an acute, looks like that. For a right, looks like that. For an obtuse, looks really weird. All right, up next, given a right triangle, where's the centroid located? The centroid's always going to be located inside the triangle. And that's because it's your center of gravity, okay? And it makes that 2-to-1 ratio that we're going to see in this next part. W, well, if W is made up of a bunch of medians coming together, then W should be the centroid. The centroid makes that awesome 2-to-1 ratio. So if MW is 22, MW is 22, then WY, well, since MW is the big piece of the 2-to-1 ratio, WY is going to be the small piece. It's going to be 11. WY equals 11. What is NW if ZW is 10? NW if ZW is 10. Well, ZW is the shorty. It's the 1 part. So the 2 part is going to be double that. It's going to be 20. So NW is 20. And then what do we got next here? If PW is 13. All right, so PW here is the long piece. It's 13. And if the long piece is 13, then the shorty is going to be half of that, 13 divided by 2. I think that's 6.5. All right, so none of these asked about the whole segment. That's kind of weird. Honestly, you got to make sure you know the whole segment too. Like if I said, hey, NZ is 30. What is WZ? So if I asked you a question like that, you would have to know to take the whole thing and divide it by 3. So take the 30, divide by 3, and you get 10. So make sure you know if you have the whole thing, you have to divide it by 3 to get the shorty. All right. And then the last up on this page here is a farmer wants to place a hay bale so that it's an equal distance from the 3 points. Dude, equidistant to the 3 points, that's supposed to be a hay bale there. Okay, that's not what a hay bale looks like. Let me fix that. A hay bale looks like this. There you go. There's a bale of hay. So the hay bale needs to be equal distance to all three of those points. Well, equidistant to the three vertices is the circumcenter. Okay? Equidistant to the 3 points, or vertices. All right, all right, all right. Which of the following lengths can form a triangle? Well, remember the rule. The two sides need to be greater than the third side, the biggest side. So 2 plus 4 has to be greater than 5. It is. So that's good. 2 plus 2 has to be greater than 4. It's not. So it doesn't work. 3 plus 4 has to be greater than 5. And it is. So it works. 22 plus 33 has to be greater than 57. And it's not. So it doesn't work. 28 has to, and 29 has to be greater than 55. And it is. So it works. All right, guys. So the two sides, the sum of the two sides, needs to be greater than the third to make a triangle. The next one says, write an inequality expressing the range of values of the third side. Now, we learned a shortcut to do this. The shortcut says that your missing side, your third side, is going to be between two numbers. The top number will be found by adding the two other sides, 9 and 15. So our third side has to be less than 9 plus 15, 24. So we're going to be less than 24. Our third side has to be smaller than the difference of the other two sides. The difference of 15 and 9 is 6. So we're somewhere between 6 and 24. You cannot be exactly 6. You cannot be exactly 24. You're between those two numbers. All right, cool, 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 which will help us with the next problem. A jewelry designer plans to make triangular pendant out of gold wire. All right, all right. We don't know what the third side is, but I know the two sides are 10.5 and 2.5. So this third side is going to be between, well, add them up to find the big number, subtract them to find the small number. When you add them up, you get 10.5 plus 2.5, 13. So the biggest it can be no longer than 13. The smallest, it can be no shorter than the difference of those two, which is 8. I wrote that backwards. I need to fix it. Sorry. It can be no longer than... Oh, sorry. It must be longer than. My bad. Reading is really hard. Bigger than 8, smaller than 13. Our range of values. Now, here's the deal. We want to find out how much it's going to cost us. So it's going to cost us $31.65 per centimeter, but I need enough material to make the whole thing. So the smallest we could do, the minimum cost, it will cost no less than 10.5 plus 2.5 plus 8 is the amount of material I need. What is it, copper? Gold? What are we? Oh, gold. That's the amount of gold. Then I'm going to have to multiply it by 31.65 because that's the cost of the gold per centimeter. So let's do that. Let's figure out how much material, how much gold I'm going to need. And that's 13 plus 8, which is 13 plus 8, 21? So 21 times the amount of the cost of the gold here, 31.65. And this is going to cost more than $664.65. So that's the cheapest it could be. Now, if I use the bigger value, so this was using the small value. If I use the big value, it's going to be 10.5 plus 2.5 plus 13, which is 26 centimeters. And I have to multiply that by 31.65. So the most expensive, we're going to pay no more than $822.90. So it's not going to cost, it's going to be more than 664.65, and it's going to be less than 822.90. All right. So honestly, don't spend that much money on I don't know if he's buying this for his girlfriend or something. That's a lot of money. Just be nice. Maybe flowers, maybe a nice dinner. All right. What is the longest side of this triangle? XYZ. I totally suggest you drawing it. XYZ. If X is 60 degrees, Y is 61 degrees, and Z is, I don't know. Well, let's figure out what Z is. I know a triangle has to add up to 180 degrees. So angle Z is going to be 180 minus 60 minus 61. Throw that in your calculator. It's 59 degrees. So we need the longest side. The longest side is going to be connected to it's going to be opposite of the biggest angle. So opposite the biggest angle. So find your biggest angle, and that will point you to the biggest side. So the biggest side should be XZ. All right, all right, all right. So I totally suggest you drawing the triangle. Makes it a lot easier.